Before we continue our lecture about asymptote, let's take a quick revision about limit at infinity in cases which we have indeterminate form. You notice that we already discussed a few questions in the tutorial, but from the lecture notes, right, indeterminate form for limit at infinity, the cases is such as this one. As you can see in example 24, if we direct substitute x with the infinity, we get infinity minus infinity. So this is what we call indeterminate form also. It's not limited to 0 over 0. In previous cases, which we will use conjugate or multiply with conjugate or factorize. But also in this case, for limit at infinity, if in encounter cases such as infinity minus infinity from direct substitution, so this also represent the indeterminate form. So for polynomial function like this, in order to solve the question correctly, so what you need to do is we factorize the highest degree of x. So as you can see here, the highest degree of x is x cubed. So we factorize x cubed outside like this, and then inside we have a constant over x and also over x cubed. So later when we substitute x with infinity, so as you can see outside here is infinity, and these two, as we know, it will become 0, right? So this is what happened. So at the end, the answer is infinity. Okay. Next, the second cases here is for irrational function. Also, as you can see here, if we direct substitute also negative infinity, so inside here negative infinity squared minus infinity. So infinity squared, we got infinity out inside here, and then outside here plus negative infinity. So outside here also infinity. So at the end it is infinity minus infinity also. So this also indeterminate form. So for irrational function like this, what you need to do is we need to multiply with conjugate. So if we multiply with conjugate, don't forget we also need to divide with the conjugate. So that's why it's mentioned multiply and divide here, means above and below. Okay, multiply with conjugate. Then after we simplify, we will have a conjugate below here, and above here we have only 2s after we eliminate the x squared. And then next, what we'll do is we divide with the highest degree of x. Okay, so in this case, since x approach infinity, so we know square root of x squared can be positive or negative infinity. Positive or negative x. So for x approach infinity, negative infinity, so it will become negative x. But in the cases here, they already move the negative to outside the set. Okay, but it's actually the same cases. Okay, and then what will happen? So we divide. So above here with over x, and below here with over x squared here. So I prefer we write down like this, over x squared, and then put the negative outside here. Okay, and then okay, so that's more like it. And then when we approach infinity, infinity, so this one will become 0. So that's what happened below here. So at the end, actually here it will be negative 2 over negative 2. So that's why the final answer is 1. Okay. So that's the second cases. And now the third cases, when we have rational function. So for rational function, look at example 26. So when x is not only limited approach infinity, but in these cases, so when approach 2, so this one will become infinity also. Okay, this one will become infinity because 4 minus 4 is over 0, so that's why it will become infinity. Same also here, over infinity. So at the end, it still will become infinity minus infinity. Okay, so that's why it's stated over here, infinity minus infinity, right? So for these cases, the method to solve this one is to reduce the common denominator. So means that we equate the denominator, right? So equate the denominator. So as you can see, we multiply this one with x plus 2. So here already 1. Okay, so 1 minus this one to add, and then this one multiply with x plus 2 to equate denominator. This one already x squared minus 4, so no need to multiply. Remember the partial fraction equate denominator. So this is what concept we will do. Okay, next. So after that we simplify. Okay, then after we simplify, okay, so this is what we call reduce the common denominator. So below here the highest degree is x squared, so we divide above and below with x squared, right? So divide with x squared, so we got negative 2 minus 4 over x plus 1 over x squared. And then below here, we got 1 minus 4 over x squared. So later, when x approach I think it's supposed to be approach infinity, right? But this one approach 2. Approach 2, there seems to consider only this one. Okay, more or less like for x approach infinity actually. Okay, and then we will get the answer is negative 2. So that's the method. Maybe some of you will confuse how come this one becomes 0, right? Suppose we substitute x with 2, right? But this is what happened in order to solve this kind of question. Okay, so I hope you take your time to understand the solution for this exam, the questions. So that's all. So I hope you can try to answer this exercise and obtain the answer. So to make sure that you fully understand about this concept of limit at infinity. So until now, thank you very much.